would that be?
Negative infinity to -1 with a bracket.
That's it. Awesome. Can anyone give us the interval for this, the interval notation for that?
-1 to infinity.
With a parenthesis because there is no equal symbol. Awesome. So now can anyone give us the domain of this function? Not of this, not of this, of this function. What is its domain?
Would it be negative infinity?
To infinity.
That's it. Excellent. We have everything between negative infinity and -1, including -1, and everything to the right of -1 to infinity. Good. 0 always has to be in the table, but of course this is the key value. So this is the key value for x, y, because the function changes from this to this. Between negative infinity and -1 with a bracket underneath, bracket, this bracket, and the parenthesis touching it. When they don't touch, then they have to be parentheses if they don't touch. And here maybe another number or nothing. But a bracket and a parenthesis, they always have to touch. Two parentheses will not touch. But a bracket and parenthesis or parenthesis and bracket, they have to touch. Here they don't. Okay, so again, between negative infinity and -1, I have x plus 3. Why I do this? You can say this is an overkill. Possibly. But these branches, they're not always presented in the correct order. And what if I choose here -3 and plug it in this by mistake instead of plugging in this? So that's the reason why I do this. I put them on top just to make sure. I chose -3 because that's the x-intercept, so that would be 0. We will plug in -1. What do we get inside the bracket?
2.
Very good. Awesome. Now let's plug in -1 here. And you should say you can't. You can't plug in -1 here with an equal symbol and here as well when there is no equal symbol. But remember what the issue is. If we do not plug in, and this tells us to leave it open, but if I don't plug it in, then I have to start with -0.9999999, and so on and so forth. Who wants to do that? No one. So let's plug in -1 and inside the parenthesis. So this will be full, and this will be open. Sorry about that.
0.5.
Say it again.
0.5.
Yes, yes.
1/2.
1/2. Excellent. So let's plug in 0.
1.
Excellent. And let's plug in 1. Notice one thing again. Negative infinity, -3, -1, 0, 1, infinity. Do not put 1 in here and -3 here. Everything is in ascending order. So when I plug in 1, I get 2. That's all I need. Now I didn't ask, what type of function is this? I make myself a note. What am I graphing with this?
Linear.
Good. But what am I graphing with this?
Exponential.
Exponential. With a base greater than 1. And this is, I never thought I would say this, but well, basically it's a function specific for bacteria and other things. So this is the exponential function with a base greater than 1. So this is exactly what we've been experiencing for 2.5 years. And when they said, we are trying to flatten the curve, they were hoping for this. Well, we were hoping for this, but at least this, flatten the curve. That's what they were talking about. Okay, so I start with -3, 0, full point. I continue with -1, 2, full point. I know that this is linear. I'm done with this, just to make sure I'm not continuing with the same, extending it. If I do extend it, I'm done. I can't get any credit for it. The next one, -1 to 1/2, which is an open point, because I'm not allowed to plug in -1, right? And then 0, 1, and then 1, 2. That's the problem with this function. See how fast it's going to infinity, the fastest possible. You do not, I repeat, you do not have to use 2 colors. No, it's the same function. However, the reason I am using 2 colors is because I don't want my students to do this and then graph this on top of it. I've seen it, and I will see it, unfortunately, on the next test. I know that. So my students, at least one, for some reason, although I say it over and over, this is not the function by the vertical line test. See, x plus 3 only from -infinity till -1. Done. 2 to the x only from -1 to infinity. Done. You cannot extend the orange to the left. You cannot extend the green to the right. So now, looking at this graph, what can we say? Is this function continuous everywhere?
No.
No. Where is this function discontinuous, and what type of discontinuity?
-1.
Discontinuous at -1. What type?
Movable.
Okay, let's go back.
Is it a jump?
Yes. Removable is this. The limit from the left and the limit from the right are equal. They both exist and are equal. Here, the limit from the left and the limit from the right are not the same. So this is a jump. Is this function continuous from the left or from the right? Or none?
The left.
Yes, continuous from the left. So in other words, the limit, and you can see it here, right? The limit from the left is 2, and the function value is 2 at that point. So limit of f of x as x approaches -1 from the left equals f of -1. And they are both 2. The limit from the left and the function value are the same. They exist. They are the same. They equal 2. Now, I just wanted to, because I don't want to go back to the first page, I want to put it here. You can put it in both places. I should have removable discontinuity has again this property. The limit as x approaches a from the left of f of x equals the limit of f of x as x approaches a from the right, but the only thing is that it does not equal f of a. So back to the graph. Again, the limit from the left equals the limit from the right, but does not equal the function value. Or the function is not even defined there. One or the other. Good, that was a good pick. I want to look at 47, and then we can move on to the intermediate value theorem for continuous functions. So let me share my screen. Here it is. I'd like to look at 47. This one. For what value of the constant c? I see c here and I see c here. It's also called the parameter. For what value of the constant c is the function continuous everywhere? So I'm going to copy the function f of x, cx squared plus 2x for x less than 2, and x cubed minus cx for x greater than or equal to 2. When we have a situation like this, we have to state, number one, what type of function is this? C is a number, any number. What type of function are these? Cx squared plus 2x and x cubed minus cx are?
Polynomials.
Polynomials.
Yes, continuous everywhere. Excellent. As polyfunctions. So where does this come? Where is this coming from? Very simple. From what we just stated a second ago or a minute ago. We are stating a theorem. Good. So in other words, this piece is continuous to the left of, it doesn't matter, it's continuous everywhere, but in this case it's continuous to the left of 2. And this is continuous to the right of 2, although it's continuous everywhere, but this is defined only to the right of 2, and this is to the left of 2. Fine. So now the second step is study continuity at x equals 2. What has to happen at 2 for the function to be continuous at 2? What do I have to write and determine? Not just write, but also determine. What is the definition of continuity at a point? Definition of continuity at a point. What did we say? Anyone? How do I start by writing the definition of continuity at the point?
The limit as x approaches 8 from the left.
2 from the left.
F of x
Excellent. Good. Equals?
equals the limit of as x approaches 2 from the right.
Very good. Must equal f of?
F of 2.
Excellent. Brilliant. Thank you. What do I put in here? Anyone?
Cx squared plus 2x.
Very good. Awesome. Thank you very much. I know it's silly, but I'm going to ask, what do I put in here?
X cubed minus cx.
Very good. Awesome. Now let's work on these. So what I'm saying here is this. For that function to be continuous at 2, this limit must equal this limit and must equal the function value of 2 at 2. If this cannot happen, this function will never be continuous at 2. So let's see if it can happen. If I can find this little c that says, yeah, if you put c in there as being blah, 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 then it's guaranteed. Okay. So can anyone give us this limit? This limit of the limit of this polynomial function when x approaches 2. What does this equal to?
C4 plus 4.
Excellent. When x approaches 2, 2 squared is 4 times c plus 2 times 2. That's how we know from last time how to determine limits of polynomials. Equals. Can anyone else give us this limit?
8 minus 2, 4.
Good.
Or 2c.
Excellent. Can anyone give us f of 2? And now I'm going to ask you, which branch will you use to find f of 2? Are you going to use the top or are you going to use the bottom?
Bottom.
Perfect. So you will say 8 minus 2c again. Okay, there is no need to write it again. So f of 2 equals 8 minus 2c. Good. So can we solve this equation for c?
So,
Good. So I'm going to add 2c. I'm going to subtract 4. And I'm getting 4 over 6, or c equals 2/3. All I have to do now, put it back in the function. So this function, if it has 2/3 x squared plus 2x, and x cubed minus 2/3 x, what can you say about this function? Is or is not continuous on everything?